Hareesh. Hareesh heads application engineer at Svaya Robotics, where his team develops plug and play solutions to enhance manufacturing productivity and flexibility in manufacturing facilities. Harris brings a wide experience with his work in ABB India, Atlas Copco, Wipro PARI, and ACIETA USA in various capacities. Today, Harish will share his insights on Cobots for flexible automation. Please welcome Mr. Harish.
Ms. Alka had given a very good overview about the challenges as well as the things that are generally seen in the collaborative robots. I would be probably taking it further on my topic related to that. And Mr. Anup Singhal has given a good overview about the different types of applications where you would be seeing the robots as well as the collaborative robots being used. So my focus here would be on cobots used for flexible automation. So if you see the picture that I have on the right side here, you see an operator who is doing some task, and there's a collaborative robot that's right next to him, and even the robot is doing some task, and they're right next to each other, and they're working in tandem. So generally, as humans, we always like to do something that is complex, where our brain is required. That when I say brain, I mean we like to do things where there's some intelligence which is required, and we have to put our brain in doing that task. That's one type of task that we would like to do, or the other where our skill is being utilized. When there are tasks which are repetitive and it is just the same repetitive thing which is boring in nature, we tend to generally lose the interest in it, and we try to go away from it by probably switching over to other companies or trying to get into a different type of work. So that's a general challenge that the industry sees, that people generally try to move on. And so finding new people, training them, and then putting them onto job becomes a major challenge that the company sees. So what we propose as Svaya Robotics is that the simple repetitive tasks have to be done by the collaborative robots, and the more complex ones, which needs the intelligence or the skill, should be done by operators. So as we had already discussed before, it's not about replacement of the operator, but to enhance the operator to do more complex things and to give the boring tasks to the robots. So through this process, we will be increasing the productivity, making the environment more safer, and making the work more simple. So cobots should be on applications. There is human interaction, and which is all applications which are all human centered in terms of the solutions. What you see on the screen are three different things in terms of the way the work can be done. If you see on the left side, it's a manual workflow where people are doing the continuous labor intensive work. Generally, these are harsh in environment. And again, since it's a harsh environment, what you see is attrition in the factories. So people come, they are excited, they do the work for a few months, let's say probably 1 year max, and then they realize that this is not what they want to do for the rest of their life and to move on. And so generally, MSMEs have a major challenge there. It's not about cost, it's about having the manpower, retaining them, and training them. The upskilling them is a continuous process for them because people are always leaving. So generally what they look for in terms of the solution is on the right side extreme, which is the all-out automation, because that's what people are generally familiar with in the last few decades, which is probably using of industrial robots and trying to go to the other extreme where robots do everything. So when you go into this field where you want to make the robots do everything, because generally what happens is in factories, the management tries to look for the most complex task and tries to assign that to the robots. So they try to automate that process because they feel it's complex. So when you try to do that, the solution is also complex. And so your investment also increases significantly. At the same time, the other challenge that they face is that this is more of a rigid solution. So if at all they have a new variant, new modifications that they need to do or improvements in it, it becomes a complex thing because they need to again call in the experts from that field, whether be the robot programmers or the integrator who has provided the solution. And they have to put a lot of extra efforts in terms of the money, time to make it and to enhance it to meet the new requirements that they have. So for that reason, again, there are a lot of management in MSMEs who try to avoid getting into this. And so they are more happy with the left extreme, but they know that that's a always continuous challenge. So the solution to the problem here is the one that you see in the center, which is the human-centered automation, where it is bridging the gap between a manual workforce and a all-out automation. So here, when you have robots or the collaborative robots and operators coexisting together, you can make or define the task which helps in their coexistence and makes the operators happy. They would be doing more skilled work, and also they would get easily trained on how to control and operate these collaborative robots. So they are also enhancing their skills. So they will feel proud and happy about what they are doing. So this is helping you in retention of your employees, and it's also helping you in increasing your productivity. So generally, robots do not replace people. They increase the productivity or the outcome that you have from your factory. That's what generally it does. But people have a different perception, which people who are into this field have to keep on educating the end customers. So we feel that there's a huge scope in the MSME in terms of the area in penetration that can be done, because there are a lot of customers who are hesitant to go with all-out automation, and there is always a scope for collaborative robots to get into those space, which helps them in getting the flexibility that they need for automation. At the same time, it gives them it empowers them to ensure that they have the control of what is being done at their facility. So here, I would like to highlight some of the general differences that you see in a industrial robot versus a collaborative robot. So here I'm focusing on the hardware as well as the software that you see in general, as well as even in the robots developed by Svaya. Just for your information, Svaya Robotics is India's first collaborative robot manufacturer. We have gone through a decade of R&D. So we are a completely Make in India company. The entire R&D has happened in India, and we manufacture them in Hyderabad. So now I would go from the left to right in terms of the things that you see on the screen. The leftmost is talking about the engineering, which is the hardcore design of the manipulator that you see. Industrial robots generally use servo motors, whereas in the collaborative robots, you have a BLDC motor, and the drive is also a part of the joint. In every joint, you will have a drive which is inbuilt into it. Whereas in industrial robots, the drives are all part of the controller, which is slightly external. This is how it's designed because you need a quick, fast response, and this integrated design helps it light as well as agile. So even the electrics, that's the electronics and the power management is also slightly different from the industrial because you have all the drives internally in the articulated arm, as well as there are a lot more features into it. The third one that you see is the interface. So the way earlier we used to have phones with buttons in them to operate, iPhone revolutionized it by making it user-friendly. So collaborative robots have also generally revolutionized the way the robots are perceived because of their interactive nature. You have the touch screen, and the interface that you have, the UI UX, is made very user-friendly so that any person with less experience or exposure to robots will be able to learn and use it very quickly. So that has been a focus of Svaya Robotics as well. And we continuously strive to ensure that our interface is very user friendly, wherein any person from India who has the basic education as well as the basic skill set should be able to pick it up very quickly. So the next one, what you see is the digital twin. So you have the actual articulated arm which is moving around in air and doing a specific type of task. In a similar way, you have a digital twin on your teach pendant that you are holding in your hand, and it's replicating what the robot is doing. So this digital twin helps you in a lot of ways. Let's say the robot is doing a task for a specific application, and you want to create a new program for the next variant that might be in your list of things to do. Then you can program it offline, run it in the simulation in the digital twin offline, see and gain confidence that what you have written is right, and then you can switch it to online and make the actual robot do the work. So through this process, you are significantly decreasing the time it takes to do the programming, and also you are making it fail proof. Like, since you have the digital twin, you are running it offline and seeing and ensuring that your program is correct. So the possibility of the actual physical robot going somewhere and hitting and getting damaged is not going to happen. So you are empowering the programmer and making the overall system more safer in terms of its machinery. Then the next topic that you see here is the collaborative nature of the cobots. So this collaborative robot, what it means is that when you have a robot, for example, moving around after in a task, let's say it's a pick and place application, and the robot is moving around, and for some reason someone physically comes and stands next to it without his knowledge, the robot would hit him and stop immediately. When I say hit, it is not really impacting the operator. It is sensing a minor, small increase in the force that it sees, and it has sensitive sensors in it, which helps it in sensing that there is something that was abnormal that has happened. And so it would quickly come to a standstill. So that makes collaborative robots safe. And that's the main advantage it has, which is making people go towards more of collaborative robots when compared to the industrial robots. Then the next point, what you see is the perception. So one of the advantages that we have as humans is that we have the feel of touch. So if we touch something, we can feel it. Why are we having that? Because we have sensors in our fingers, which helps us, or throughout our body on the skin, which helps us in feeling that touch. So since the collaborative robots have joint torque sensors at each and every joint, and it is very sensitive to feel that small increase or decrease in the force that it is seeing, it helps in making it feel and act like a sensitive person with the feel of touch. So if there's slight force increase or a force decrease, it would be able to sense it. In the same way, let's say you have an application like surface finish, where you are applying force based on the contours that you are going through. So let's say there is a wooden part that has to be finished in terms of the surface. It's having ups and downs in it. So when an operator is doing it, without our knowledge, through our intelligence, we adjust the force so that it goes through that contour. Whereas a general industrial robot will not be able to do that. It would just go through a part of the program that it has. Whereas a collaborative robot will have such features, or you can make it do such tasks where you define the force it has to apply, it would adjust based on the location it is and dynamically adjust its position. So these are all different features that collaborative robots brings onto its table. The last one, but not the least, is the no-code interaction. So this one of the concerns that generally factories have is that if you put a industrial robot into your factory and you need some changes because of the new variant that you have, so you need to call a programmer from the specialist company who needs to train the robot. So then you're talking about downtime. We are talking about calling someone from somewhere, placing a purchase order to that company, probably for a couple of days for their engineer to come and program it. So this is all the burden that they think of when they think about putting a new robot into their factory, and if they do not have anyone trained on it. So collaborative robots have features like no code interface, which I would be showing later on, as well as the lead through programming, where you can hold the robot with your hand and move it as required and teach the points. So such features makes it a lot easier to use the robots. At the same time, it builds confidence into the customer, saying that I can train my people, they can do this work very quickly and easily. And so I don't have to worry about putting a collaborative robot into the factory. So these are some of the salient features that a collaborative robot brings onto its table. Some of the features about Svaya robots that I would like to highlight in this slide is that uh, we have designed and developed our robots to be versatile in nature, wherein the end of arm tools can be easily connected and it can work for different types of applications. The plug and play option that we provide and the interface that we provide makes it very easy for anyone, any novice to take over the tasks that are required. They are high in precision. They are on par with other kinds of robots that you would see in the market. They are easy to install. Ms. Alka had told that the robots are a lot lighter in weight. That's a major thing. These are all made of aluminum body. And so a regular operator will be able to easily lift a robot with 16 kg payload with his hand because of its weight. Whereas an industrial robot, you can never think of it. So because of that, you can probably put it onto a small cart and push it around your factory wherever you want and use it as required. We have spoken about safety. The sensors in it makes it safe to be right next to humans. So you don't need any fence or a cage around it. And the built-in sensors, as I have stated, makes it sense and makes it useful for a lot more applications. The last but not the least, in India, we have a lot of dust and the environments in factories aren't that great. And for that reason, we provide IP67 protection as default throughout the body, because that's one of the concerns that generally customers in India have, whether we are doing machine loading application where you have a lot of coolant, or you're doing some kind of a grinding application where you have a lot of dust in there. So this IP67 would take care of it. So what we say is create, connect, and collaborate. So when you use a collaborative robot, it's very easy to create the code that you need to make it work. So you are not programming, you are teaching the robot. Then it is easy to connect through the interface as well as the ecosystem that's being provided around it. I'd taken an example of an Apple before, where I said it made it a lot more easier. In a similar way, probably even Android as well. The reasons why we like them is that it's not just the software that comes with the phone, but if you go to probably Play Store, you have n number of apps that you can install and make it work with it. In a similar way, for the collaborative robots, there are a lot of companies developing the solutions which can be easily connected and make it plug and play. So that decreases the burden as well as the work that needs to be done to put it onto the factory. So last one, collaborative robots. What we mean is the collaboration is that you have the digital twin, which helps it in making it connected a lot more easier everywhere and make it on the fly. So you would also have data analytics, which would be a part of the teach pendant itself. So generally, when we think of data analytics, we think of probably a separate software that you need to purchase, get it installed and make it work. Whereas cobots like Svaya would have this as a default. You can see the health status as well as your application data to ensure that you are always having the robot doing its best. So I would like to just show a small video here. You would see here robot programming or teaching in two ways. One is the block leave, where it's easy to drag and drop. The other is the operator is moving it with his hand and teaching the points. So these features makes collaborative robots very easy to use. So when you look at the flexibility in automation, I would say SPMs or special purpose machines for automation would be less flexible, and gantry would be slightly flexible. Industrial robots slightly more flexible because of its 6-axis, and collaborative robots are the most flexible ones when you think about automation. So for batch production, collaborative robots would be the best thing to go with. So to close up, all I would like to say is that flexible automation is all about fast and easy teaching that the cobots bring, the plug and play ecosystem, which helps in making it easy, and the user-friendly analytics tools for real-time analysis, again, is another added benefit that the collaborative robots bring onto the table. And in last but not the least, it brings autonomy to the line worker. You don't need someone specialist. You have your own line worker quickly getting trained onto it, and he's ready to go and use it as required. Thank you, everyone. Thank you for your time.
Thank you, sir, for talking about the use of automation while deploying cobots.